Today's vast and powerful telescopes are taking us on an unimaginable quest to unlock the secrets of the cosmos.
They are going to tell us in detail what our universe is made of, how it was born, how our universe is evolving.
They take us back to the dawn of time, to the very birth of the universe, show us giant clouds where stars and planets are born.
Each time a new telescope looks in a different way at the universe, we learn something new and profound about the universe.
In stunning clarity, we can now watch stars exploding, galaxies colliding, and the violence of black holes.
There's a whole hidden universe out there.
We see the universe continuously changing and evolving.
Revolutions in technology and ever larger telescopes are pushing forward the frontiers of space.
Every time you try and explore a new part of the universe, we have these great discoveries and these great surprises.
But where did this race begin? Where will it take us? This is the remarkable journey through 400 years of an extraordinary device that is changing everything we thought we knew.
Telescopes have revolutionized our understanding of ourselves and our place in the cosmos and our mindset about who we are and where we came from.
Hunting the edge of space. Up now. Giant doors 8 stories high slide apart. These twin eyes are preparing to look into deepest space. They belong to the Large Binocular Telescope. It is one of the most powerful telescopes on Earth, costing over $120 million. These 28-foot wide mirrors collect light from objects millions of times fainter than anything our eyes can see. 600 tons of machinery turn the mirrors to look more than 13 billion light years away, to the very edges of the visible universe. Super telescopes like this are taking real images that illuminate the darkest corners of our skies. Billowing clouds of gas and dust are buffeted by supersonic winds and lit up by thousands of energetic new stars. 57 trillion miles high, these giant clouds of gas and dust are stellar nurseries, hiding the very birthplaces of stars and planets. Suddenly, a star's explosive death sends its superheated gas ripping through space at hundreds of miles per second. And in faraway galaxies, we can take images of invisible jets of energy screaming out from one of the most mysterious objects, a supermassive black hole. All because of high-tech telescopes.
The telescope has changed the way we as a species think about ourselves.
With a new telescope, you're always going to find something new because you always add to your ability to see more.
These breathtaking images are only possible because extraordinary telescopes like these are staring out night after night across the globe and in space. Over the past 4 centuries, revolutions in technology have transformed this groundbreaking instrument. So where did it all begin? The journey starts with one man and 2 pieces of glass. It is the summer of 1609. Mathematics professor Galileo Galilei is building his own version of an extraordinary new invention. It is the telescope, a name that means far-seeing in ancient Greek. The invention has spread like wildfire across Europe from a small town in Holland. Spectacle makers working on the most precise glass lenses of the day discovered that two different types of lenses held at just the right distance produce a surprising optical effect. They act like a magnifying glass for distant objects. This is the birth of the telescope. Galileo immediately sees the potential of the invention.
Galileo is a practical mathematician. That's his trade. He designs instruments, he teaches the use of these instruments, and these instruments are often used for warfare.
Galileo works out how to increase the magnifying power of the telescope to 8 times what our naked eyes can see, and he hits on a military use for it.
And it would be particularly advantageous if you could see the enemy before he can see you.
The Venetian military buys this new device as a spyglass for spotting enemy ships. But then, Galileo turns his telescope from the Earth to the sky and starts a revolution.
By turning the telescope to the heavens, Galileo enters a whole new regime of practice there, where this instrument can be used to discover things we didn't know before about the world.
All astronomers knew of the heavens before Galileo was what they could see with the naked eye, the stars and the moon. But today, even amateur astronomers can see much, much more. Alexandra Hall spends her nights gazing up at the night sky from her backyard.
I never get bored of looking at the night sky above our heads. It's like 2,000 diamonds sprinkled across black velvet. And then the moon arises. And watching the moon go through its phases, I mean, it looks different every time you look at it.
To the naked eye, 5 stars sometimes appear brighter than the rest, and watched over the course of nights, they seem to move against the backdrop of the other stars.
And they don't just stay in the same place like all the rest of the stars. They move around. Sometimes they're visible, sometimes they're not.
Each of these bright stars is a planet, a name that simply means wanderer in Greek. Venus, the evening star, skims the horizon at sunset. Mars glows red. Jupiter and Saturn outshine everything around them. We now know that these wandering stars are actually other worlds, like the Earth, planets as we understand them today. But in Galileo's time, everyone believes they are just stars. There is only one world in the universe, our Earth, and it sits at the very center of everything. The sun appears to circle the Earth during the day, and over the long course of the night, the moon and stars also appear to rotate across the heavens, circling the Earth in giant orbits.
When you stand outside, even just for a few hours at night, you suddenly notice that all the stars and the planets and the moon, everything is wheeling around your head. It's like you're at the center of things. Really quite a powerful feeling.
But Galileo is about to show that this is just a feeling. He starts to shake the known world order when he looks at the moon. The belief in his day was that all the heavenly bodies were flawless.
In the old cosmology, the moon was a heavenly body and therefore perfect.
But looking across 250,000 miles of space, Galileo sees something very different from the smooth sphere he expects. He sees instead a moon scarred with craters and valleys.
It must have been an extraordinary moment for Galileo to peer with his little itty-bitty crummy telescope at the moon and see craters, mountain ridges, valleys. he saw for the first time geographical terrain on another astronomical object.
This means our Earth is not unique in the cosmos.
These patches that you see are mountains. The moon isn't smooth. It's like the Earth.
But this is just the beginning. Next, Galileo turns his telescope on Jupiter, one of the wandering stars. He sees it as no one has ever seen it before. This is an exact computer reconstruction of what Jupiter looked like through Galileo's telescope. Calibrated on Galileo's actual lenses, it shows what a challenge he faced. A replica of his telescope reveals how hard it is to get a still image.
Well, when I actually got Jupiter in the telescope, it was really difficult to focus because the lens quality is not very good compared to the lenses that we would get today.
To the naked eye, Jupiter looks like a bright star, a spot of light. Seen through Galileo's telescope, all other stars remain as spots of light. But Jupiter suddenly appears as a much larger, round disk. This blurry, shaky view of Jupiter is a revelation. Galileo comes to an extraordinary conclusion. Jupiter must be a sphere, another world, a planet as we understand it today. And around it are even more surprises.
Picture yourself, you've just glued a little piece of glass on the front of a long tube, and to your utter surprise, you see 2 or 3 or maybe even 4 stars next to Jupiter, like little ducklings following a duck.
Night after night, Galileo notes the changing position of these new stars.
Imagine your surprise. Why should stars be following Jupiter? And of course, Galileo learned only after a week or two of watching those little ducklings following their mother that those, in fact, were moons orbiting Jupiter.
Galileo knows he has something spectacular on his hands. He publishes his findings in a book called The Starry Messenger.
It is the most explosive scientific book ever written. Its impact was immediate. Galileo became a superstar overnight.
But the biggest revelation is yet to come. Galileo is recording something that will change our view of the universe forever. He observes the planet Venus changing shape and size over a period of months. As Galileo watches, Venus transforms week after week from a large crescent to a small round disk. Then shadows creep again across the planet, returning it to a large crescent. To Galileo, the pattern of shadows he sees on Venus can only mean one thing. Venus is going around the sun. But the belief at the time was that everything circled the Earth. Earth is no longer the center of the cosmos.
And so it's said to us, wow, we're not at the center of the universe anymore.
These very simple observations literally rock the foundations of the world. No longer is the Earth the center of the universe. The sun is the center of the universe, despite what our ordinary senses tell us.
But these discoveries famously bring Galileo into direct conflict with the Roman Catholic Church. The Church taught that God placed mankind on Earth at the very center of creation.
Defending a sun-centered universe, Galileo was actually challenging the authority of the Church. He was contradicting what was considered as the legitimate interpretation of the Bible, and the Church couldn't tolerate this.
But what Galileo saw is the solar system we understand today.
The discoveries that Galileo made, they changed the world forever. The world of science, the relationship between science and religion, and the universe forever.
This is the universe Galileo helps reveal. Planets and their moons orbiting the sun. Telescopes today now reveal this solar system in detail that Galileo could only dream of. Explosions on the surface of the Sun the power of 1 billion megatons of TNT. Features in the Great Red Spot on Jupiter, a vast stormy vortex large enough to swallow 3 Earths. On Jupiter's moon, Io, we can watch volcanoes spew ash and gas high into space. On Mars, a canyon 5 times deeper than the Grand Canyon. And a volcano 3 times higher than Everest. On the surface of Venus, beneath roiling clouds of sulfuric acid, mountains rise from the rocky surface. And circling the Sun at the very perimeters of our solar system, dwarf planets made of rock and ice. But one planet remains an enduring mystery for even the most advanced telescopes: Saturn and its enigmatic rings. Galileo was the first to see that this planet was different from the rest. For him, the strange features he observed looked like ears. He presumed they were moons. Later astronomers saw them as a vast flat ring encircling the planet. Then, one man discovered that this ring was in fact made up of several concentric rings. That man was astronomer Giovanni Cassini. Now, a mission named after him is investigating why Saturn has rings at all and what they're made of. NASA's Cassini mission.
3, 2, 1, and liftoff of the Cassini spacecraft on a 1 billion-mile trek to Saturn.
In the nose cone of this rocket is the space probe, Cassini. Ahead is a 2 billion-mile journey to the planet Saturn. On board the probe are sophisticated telescopes. They will investigate Saturn's mysterious rings by traveling as close to them as possible.
Good solid rocket booster separation. First stage
item 152.
As Cassini heads for Saturn, the furthest planet in Galileo's solar system, it uses the massive gravitational pull of Jupiter as a boost to slingshot it out millions of miles towards its destination.
In the world of telescopes, Cassini has some of the fastest moving telescopes in the solar system, going by at Jupiter at something like 70,000 miles per hour.
Even at such tremendous speeds, the journey still takes 7 years. But finally, Cassini approaches Saturn, 934 million miles from Earth. It dives through Saturn's outer rings to enter orbit around the planet. These are some of the images Cassini takes of the rings. They may look solid, but they are made up of billions of chunks of ice and rock, ranging in size from a grain of sand to the size of a house. And they are spread over hundreds of thousands of miles. But where is all this stuff coming from? Cassini's telescopes reveal that the inner rings are made up of material blasted off the surfaces of Saturn's moons by meteorites. But the furthest visible ring from Saturn is still a mystery. This image taken by Cassini shows that unlike the innermost rings, the outermost ring is a ghostly mist of microscopic particles. Astronomers suspect that the icy moon Enceladus could be where the mist is coming from. But until now, no one has been able to work out how. Then, Cassini's telescopes see something never observed before. vast plumes of vapor streaming from fissures in the surface of Enceladus.
These plumes go up hundreds of kilometers. That's pretty exciting to find erupting out of an icy moon.
Could these plumes be the source of the outer ring? To find out, Cassini's telescopes do something extraordinary. They fly through the plumes and taste the vapor with onboard detectors.
That's a spectacular thing to be able to do, to be able to tap the interior of an icy satellite.
Back at Mission Control, astronomers analyze the data streaming in. The vapor pouring out of Enceladus is made up of ice, salt, and ammonia. It is exactly the same material as the outer ring. It can only mean one thing. Enceladus's plumes are the source of the misty ring. This is a major discovery. Cassini's spaceborne telescopes are solving the mystery of Saturn's rings that has plagued astronomers for centuries. Telescopes today are journeying deeper into space and searching further to discover secrets that Galileo could never have imagined. But to capture pristine images like these, telescopes had to undergo a dramatic evolution. Back in the 1650s, the first step in this evolution was going to great lengths, quite literally.
Telescopes became very long, 15, 20 feet.
The problem with early telescopes was fuzzy images. The reason? The shape of the lens. As NASA astrophysicist Kim Weaver demonstrates, when a strongly curved lens bends or refracts beams of light, the light doesn't all come to a single point.
First of all, the different beams of light don't line up, and so the image that you get with this lens would be really fuzzy. Also, some of the light has its colors split out, and that distorts the image.
The only way to minimize the blurriness and the rainbow colors is to use thinner lenses with a shallower curve. Because the light comes to a focus further from the lens, refracting telescopes get longer and get greater magnification. 17th century astronomers make ever thinner lenses and space them further apart.
By about 1660, telescopes had magnified 50 or 100 times, and those lengths increased and increased and increased.
This is the first space race. On the quest to see ever further, telescopes reach absurd proportions, up to 150 feet in length, half the length of a football field. These unwieldy telescopes are better, but astronomers want to see even more detail, and these telescopes don't eliminate the rainbow colors altogether. Then, one of science's greatest minds sets out to solve the problem: Isaac Newton. He takes a look at light itself.
Newton found that white light was in fact composed of all these different colors, the colors of the rainbow.
As white light passes through a glass prism, it bends or refracts, breaking up into the colors of the rainbow. This was the root of the astronomers' problems.
Now, a lens is a kind of a prism, if you like. Once the light hits the lens and passes through it, it's broken up into its colors. So Newton says, well, we'll abandon refracting telescopes completely. There's no future in this. Just forget them. I'm going to design a telescope which has mirrors as the primary components instead of lenses.
Newton will use mirrors in his new telescope. He believes he can do this because when mirrors are curved, they bring light to a focus, just like a lens.
I'm using this lens right now to focus the light from the sun behind me. And if I hold it just right to a point on the card, oh my goodness, it's catching on fire. That was smoking.
Next up, the curved mirror.
And you can see as I bring it closer to the focal point of the mirror, It actually begins to burn the paper again.
But there's one critical difference between a mirror and a lens. The light bounces off the mirror's surface. It doesn't pass through it, so there are no rainbow colors. Newton creates a tiny telescope only 6 inches long. He makes a curved mirror only 1.5 inches across and inserts it into the base of the tube. Light from the heavens passes down the tube, reflects off the curved mirror, then reflects off a second flat mirror, and is focused by an eyepiece. This small reflecting telescope works just as well as a 4-foot telescope that uses lenses. Isaac Newton, in creating the first reflector, eradicates rainbow colors, a problem that has plagued telescopes since the time of Galileo. Today, telescopes stare out from observatories across the world and in space. They are expanding our view of the cosmos, capturing light that has been traveling across our universe for billions of years. The clarity is so exceptional that these real images continue to amaze and inspire us. All these telescopes rely on large mirrors with the perfect shape. Making them is a feat of precision engineering. Deep below the football field of the University of Arizona is a high-tech mirror lab, where glass blocks are melted in giant furnaces at over 2,000 degrees Fahrenheit, the temperature of volcanic lava. The hot liquid is spun into super smooth curved dishes. The 20-ton discs of cooled glass are then ground to within fractions of a human hair to make the precise shape. It is only when a thin film of aluminum is applied, only 100 nanometers thick, that the glass dishes become mirrors, like those of the large binocular telescope in Arizona. At 28 feet wide, these mirrors are 64,000 times the size of Isaac Newton's first mirror. And they can collect light from stars billions of light years away. In Isaac Newton's day, making large mirrors exactly the right shape is far too difficult. It will be a century after Newton before a new pioneer picks up his revolutionary design and transforms it. That man is musician and amateur astronomer William Herschel. Herschel has great ambitions. He wants to use a larger version of Newton's reflector to see further into space than anyone before.
Herschel is a musician. He's not an astronomer. He's a clarinet player, he's an impresario, he's a composer. But his real passion isn't music, it's astronomy.
Herschel wants to look anew at the night sky. He wants to look beyond the planets to the stars, and to see the very faintest stars invisible to other telescopes of the day. Herschel needs big mirrors.
He builds telescopes that are bigger than other people's because he realizes that the wider his aperture, the more light he can collect, the further he can see into space.
Making large curved mirrors, though, is still a major technical challenge in Herschel's day. Glass mirrors have not yet been invented. Mirrors are still made of metal. So working in his basement, Herschel casts discs of a metal called speculum, a special mixture of molten tin and copper. These will become his mirrors.
We don't know what the neighbors thought of this mad fiddler burning the entire road down.
Casting the metal discs is just the first step. To become mirrors, the cooled flat discs need a shiny curved surface. Herschel painstakingly grinds and polishes the metal discs by hand into the precise shape needed to form an image.
This is the reflecting mirror, the most precious component in the telescope, made in metal by William Herschel himself, made by hand. He was like a craftsman, making something which required manual skill as well as intellectual effort.
This telescope, over 200 years ago, makes a revolutionary discovery.
Or perhaps a comet.
In 1781, Herschel peers night after night into the heavens. At his side, his sister Carolyn.
Following Delta Tauri,
she records all their observations and will become a prominent astronomer herself.
Her observations were critical.
She was one of his true secret weapons.
Then, on March 13th, Herschel sees an object through his telescope that they have never recorded before. A very faint star that seems to move against the backdrop of the other stars. This wandering star is a brand new planet, Uranus.
The planets have been identified since the dawn of written astronomy. And then suddenly you have this clarinet player, with homemade telescopes in his back garden. He discovers another one. The thing is utterly astonishing.
Uranus, with its own set of rings, is the size of 63 Earths. But no one has identified it before because it is barely visible with the naked eye. 1,900 million miles from the Sun, it is twice as far from the Sun as Saturn, until then the furthest known planet. Overnight, Herschel doubles the size of the solar system. The discovery sparks a frenzied hunt for planets. It is a quest that the world's most sophisticated telescopes continue to this day. The sun is setting on Mauna Kea, Hawaii. The giant dome of the Keck Observatory opens. Its 33-foot wide mirror turns toward the heavens. Jeff Marcy is one of the world's foremost planet hunters. He is using the Keck telescope to hunt for planets in solar systems beyond our own.
Well, when you look up into the night sky, you see all the thousands of twinkling lights. Those are stars, like our sun.
Planet hunters like Marcy think that many of these stars could have their very own planets. But finding them is another question.
Your mission as a planet hunter is to find that needle in the haystack.
Telescopes only made a breakthrough as recently as 1995. They recorded a perfectly ordinary star wobbling minutely. There was some gravitational pull on the star, evidence of a planet they couldn't see orbiting around it. Exoplanet 51 Pegasi b.
The discovery of the first planet around a normal star, around 51 Pegasi, was an extremely profound moment for humanity. We now know, as a species, that there are other worlds out there.
Since then, teams of astronomers across the world have found evidence for more than 400 other exoplanets. But most of the planets discovered so far are gas giants the size of Jupiter, orbiting far too close to their suns to support life. And a planet that can support life is what the planet hunters are really after.
What we'd love to know is whether there are other Earths, habitable worlds out there, whether they are lukewarm with liquid water, having the vibrancy, the conditions suitable for life, and perhaps even intelligent life.
Looking for small rocky planets like Earth is a whole new ballgame. Cue a brand new NASA space telescope called Kepler.
And liftoff of the Delta II rocket with Kepler on a search for planets in some way like our own.
Kepler's 3-year mission is to find planets the size of our Earth orbiting other stars.
Vehicle's now going supersonic.
I think Kepler is going to go down in the history books as one of the greatest telescopes ever in the history of humanity.
Kepler's mission is to collect light from a field of 100,000 stars inside our Milky Way, looking for clues to other worlds. As the dust cover falls away, it begins measuring the starlight.
All that happens is you watch the star, and Earth happens to orbit in front of the star. It blocks a tiny fraction of the starlight on its way, and when it blocks that light, the star dims a tiny amount.
Kepler has already discovered several new exoplanets. It hasn't found an Earth-like planet yet, but astronomers believe it is only a matter of time.
I believe in the next few years we will have the first detections of Earth-like planets, places that you might indeed want to call home.
Though Kepler is looking at 100,000 stars, this is only a tiny patch of the sky. There are hundreds of billions more stars out there to search.
The hunt for exoplanets requires that we look at hundreds of thousands of stars.
So planet hunter David Charbonneau uses more down-to-earth technology.
The revolution has been to use Hubble telescopes to study the closest stars.
Using small robotic telescopes, he scans 2,000 stars that are far less bright than our own sun. This makes it easier to spot a small planet passing in front of it. And he has discovered a planet only 2.7 times the size of our Earth, a super-Earth. Importantly, it appears to be covered in water and have an atmosphere. At 400 degrees Fahrenheit, it is still too hot to inhabit, but it's a tantalizing glimpse of what is out there.
If we can succeed in finding habitable worlds, then that would have implications far beyond mere astronomy.
In a bid to find habitable planets, the professional astronomers are getting a little bit of help on the side.
Amateur astronomers are central to our understanding of planets orbiting other stars. The amateur astronomers are stationed, of course, all over the world. They have telescopes which are certainly large enough to conduct the survey.
Ron Bissinger is one such astronomer. He is following in the footsteps of William Herschel and his discovery of Uranus.
When I come up here every night and open that thing up, fire up the telescope, fire up the computer, I know the target star I'm going to look at. Everything is mine. That's my world alone. I may, for that night, be the only human being looking at that star.
He has a telescope advanced enough to help out the professionals.
Professional observatories cannot spend the time staring at one star night after night after night, but we can.
He too waits for the telltale dimming of a star's light, just one star at a time.
To find a world out there that no one's ever known of or seen or detected before, from your own backyard, a person who is not a career scientist. I don't know of any other scientific endeavor where somebody like me or so many other amateurs can do that kind of thing.
Bissinger's patience has paid off. He has already discovered several large exoplanets of his own, though all are too close to their suns to support life. Like all known exoplanets, they orbit stars within our galaxy. We know today that this is a vast collection of stars in which our Sun, Earth, and solar system also reside. But just over 200 years ago, we didn't even know we lived in a galaxy. Discovering this just by looking at the stars would be a great challenge. In 1781, William Herschel is the man who takes the challenge on. To do it, he just needs a bigger telescope. He builds a reflector 20 feet long. With this, he is able to see more stars than any other telescope on Earth, and he observes one part of the night sky in particular. The strip of stars we call the Milky Way. This will be Herschel's key to the shape of our galaxy. On a clear night, The Milky Way is a majestic spectacle. A brilliant band of starlight arcing overhead. To the ancients, it looked like milk had been poured across the sky, and it's why the Greeks first called it the Galaxias Kuklos, or Milky Circle. It's from this we get our word galaxy. It fascinates astronomers to this day.
The Milky Way stretches across the sky from horizon to horizon. It's like a big band that goes all the way around us. And so from here on Earth, it's kind of like we're sitting on the hub of a wheel, and the Milky Way is a big tire all the way around us.
Looking through his telescope, Galileo was the first to discover that the Milky Way is made up of stars. But no one knows it is a galaxy. They don't even really know what its shape is. Finding this out now becomes Herschel's obsession.
What is the actual shape of the Milky Way? We're in the middle of it, presumably. What would it look like from the outside?
He gazes tirelessly at the heavens night after night, mapping the positions of stars.
Herschel is nothing if not passionate. He's a natural obsessive. But good for him, he does something extraordinary with this obsession.
Herschel maps the distribution of all the stars he can see in a great circle that cuts through the Milky Way.
He introduced into astronomy the technique of star counts and just counting how many stars can I see.
One direction you see very few stars, in another direction you see zillions of stars. And so he plots this distribution and comes up with a view of the Milky Way.
The survey takes over a year of precise recording. Herschel finally produces a map called the grindstone because of its shape. For the first time, Herschel sees that the Milky Way is more than just a strip of stars in the sky. It is a vast disk of stars, and Herschel believes this is the whole cosmos.
When Herschel made his map of the Milky Way galaxy, to him he was making a map of the entire universe.
The edges of this star disk are the edges of Herschel's universe. Inside it lies our solar system, our sun and our Earth. The amazing thing is that over 200 years ago, Herschel almost got it right. The most powerful telescopes on Earth and in space now reveal that Earth and our solar system lie in a spiral arm in the suburbs of our galaxy, dwarfed within a giant disk of 200 billion stars spinning together around a bright central bulge that hides a supermassive black hole. The Milky Way is so large that it would take 100,000 years traveling at the speed of light, that's 670 million miles per hour, to cross from one edge to the other. Now, a new telescope is about to see what more it can find out about our Milky Way. The Herschel Space Observatory. Bill Latter is a key member of the Herschel team.
Herschel will map the entire Milky Way galaxy in terms of how stars are formed, how stars die, and how the galaxy is put together.
After years of careful preparation, the finely tuned telescope is about to launch.
Launch is a violent thing. There's no other way to describe it. We light this candle, it shakes, we throw the thing out into space, and we only can hope that it all holds together.
1 million miles above Earth, the largest mirror ever launched into space is looking beyond visible light to wavelengths our eyes cannot even see, the far infrared. This means it can measure tiny fluctuations in temperature and see right through clouds of dust to give us the clearest images of the Milky Way ever.
The results were astonishing. What we're able to see with the Herschel Space Observatory are right into the cradles of newborn stars. We see something very different than we would with our eyes. If we looked at the same region in visible light, it would be full of stars. But here, in the infrared, we're seeing dust and gas that really make up the majority of material in our galaxy, and it's where stars form.
No other telescope is able to see the Milky Way in this detail. Stars in these regions of our Milky Way were invisible to William Herschel. Yet over 200 years ago, he can see more in the night sky than anyone before him. And as he maps the stars through his telescope, one great mystery remains. Thousands of strange objects that astronomers can't explain. They call them nebulae, Latin for clouds.
There are fuzzy patches of light that you can see in the sky. They kind of look like pieces of the Milky Way that have been detached, and a couple of them you can actually just see with the naked eye. But through a telescope, there are thousands of them, and they have all kinds of different patterns and shapes and sizes. They're quite beautiful and quite mysterious. One of my favorites is the Andromeda Nebula, which you can actually see with the naked eye. And through a telescope, I can find it here. It's really mysterious. You just see this glowing light that gets brighter and brighter towards the middle. It's like, what is that?
Herschel makes a catalog of these mysterious objects, counting and classifying over 2,300 nebulae. But even with his giant telescopes, Herschel can't tell what they are or where they are.
There were little smudges that you could see in the best telescopes of the day. Those smudges were thought to be nebulae, clouds of gas, but people began wondering how far away those smudges were.
The mystery of the nebulae will continue to perplex astronomers for decades. 60 years later, at Birr Castle, Ireland, the eccentric Lord Rosse builds the largest telescope in the world. He wants to finally crack the enigma of the nebulae. 6-story walls support a tube 60 feet long, and the mirror is the height of a man.
He's a natural engineer, and if you see the great Leviathan of Parsonstown, as it's called, this great 6-foot aperture telescope, it's a vast machine.
Lord Rosse points the telescope at the nebulae. He sketches what he sees. For the first time, the fuzzy clouds begin to come into focus. Inside some of them, Rosse can see stars and spiraling structures. But there is a problem. Rosse's telescope can only move up and down, and the mirror tarnishes easily. The giant telescope falls into disrepair. It will take 80 years, a great revolution in technology, and a telescope bigger than Galileo ever imagined, high on a mountain peak, before the mystery is finally solved. This great telescope on Mount Wilson, California, will reveal that the spiral nebulae, first sketched by Rosse, are in fact separate galaxies beyond our own. The universe will be blown wide open.
It completely revolutionized our idea of the scale of the universe. No longer were we just confined to the Milky Way.
Our galaxy, the Milky Way, will no longer be the only galaxy in the cosmos. It will become just one of hundreds of billions of galaxies spinning within an inconceivably vast universe.
The introduction of telescopes to astronomy opened up an entirely new window on the universe.
The race will continue to build bigger and bigger.
Our technology has reached a point where we can build gigantic ground-based telescopes. We can launch huge space-based telescopes and see the most distant things in the universe.
The telescope is pushing forward the frontiers of our universe. So what will colliding galaxies billions of light years away tell us about our own Milky Way? And right at the limits of the cosmos, what will the afterglow of the Big Bang tell us about how our universe began?
Every time you try and explore a new part of the universe, we have these great discoveries and these great surprises.
Most surprising of all, telescopes will reveal that right now we can only see 5% of the universe.
Only a few percent of the total matter and energy content of the universe consists of things that we can see.
So what is the rest of the universe made of?
In many ways, we're at the beginning of our quest of discovery. We're learning about the major part of the universe we didn't even know existed 10 years ago.
Telescopes will point to an elusive and powerful force that is shaping the fate of our universe. Dark energy.
I think dark energy is the most mysterious thing we've ever discovered.
Telescopes are on the brink of a new era of discovery and exploration.
It's such an exciting future to think about all of the discoveries yet to come.
We are uncovering a universe we are only just beginning to understand, as telescopes that are bigger and more sophisticated than ever continue the hunt for the edge of space. Today, we are unlocking the secrets of the cosmos. Exploding stars, supermassive black holes, and screaming jets of gas. Across the world and in space, high-tech telescopes are picking up the signals that reveal a hidden universe. A cosmos almost incomprehensible in its size, age, and violence.
Telescopes have continued to open up vaster and vaster windows on the universe.
Scientists are now racing to uncover new secrets.
This is a good-looking thing.
Here it becomes
with telescopes that are bigger, higher, and more advanced than ever before.
Every time you try and explore a new part of the universe, we have these great discoveries and these great surprises.
Since the start of the 20th century, telescopes have taken us beyond our planets and beyond our galaxy to see things we never dreamed of. They've shown us the very birth of our universe, invisible matter, and the mystery of dark energy. Will the next generation solve the biggest question of all, our ultimate destiny?
Dark energy is one of the keys to understanding the ultimate fate of the universe.
Hunting the edge of space, up now. At the dawn of the 20th century, our galaxy, the Milky Way, was the entire known universe. But now we live in the golden age of cosmic discovery. Telescopes are exploding our understanding of the cosmos. Bigger than ever and working in giant networks across the globe and in space, they are unlocking secrets that astonish and amaze us. The planets of our solar system in breathtaking detail. The majestic rings of Saturn and rolling storm clouds on the surface of Jupiter. But far beyond our solar system, we are now discovering exoplanets orbiting other suns. And beyond our galaxy, another 100 billion galaxies. like Andromeda, Sombrero, and Whirlpool, each harboring hundreds of billions of stars. We've detected supermassive black holes spinning violently at the very centers of galaxies, including our own. We've witnessed supernovas, exploding stars millions of light years away, spewing out superheated gas at 600,000 miles per hour. And deep inside clouds of gas and dust, billowing trillions of miles high, we can glimpse new stars being born.
Telescopes have continued to open up vaster and vaster windows on the universe.
Now, the latest telescopes are revealing the invisible mysteries of space that we are only just beginning to understand. Dark matter, the hidden scaffolding our entire cosmos is built on. And dark energy, a powerful and invisible force that is pushing our universe apart.
Every time you try and explore a new part of the universe, we have these great discoveries and these great surprises.
Back at the start of the 20th century, the universe seems to be a much smaller place. The sun, earth, and planets make up our solar system, and beyond them are the millions of stars that make up the rest of our galaxy, the Milky Way. But that's it. That is our universe. And for astronomers, a major question remains.
A key question at the beginning of the 20th century was whether or not our Milky Way was all there was. Was that the whole universe, or were there other galaxies?
So what happened? How did telescopes come to reveal so much of our cosmos and reach to its very edges? The revolution starts in the early 1900s. A brand new telescope is being built. It will change our perception of the universe forever, explode the edges of the cosmos, and set us on a voyage of discovery that is still going on today.
That telescope is one of the most important in the history of astronomy.
The first steps in the revolution. An astronomer is hiking up Mount Wilson, a 5,700-foot peak high above Pasadena, California. He's rising above the clouds and haze of the lower atmosphere, which distort telescopic images. He wants to see if it is possible to build an observatory at the very peak of the mountain, where the air is thin and crystal clear.
There was a growing realization that for really good astronomical seeing, you had to find good sites rather than just build a telescope where you happen to have an old observatory. And people have begun to realize that the mountains in the west of the United States offered real possibilities.
100 years ago, the simple idea of putting an observatory on top of a mountain is revolutionary and an enormous logistical challenge. Hundreds of tons of steel and concrete have to be carefully hauled up the narrow mountain roads. But the clear skies are worth it. Mount Wilson will become the highest observatory on Earth and a blueprint for observatories all over the world. This observatory is the vision of one man, George Ellery Hale. His mission to solve the greatest mysteries in the cosmos, to find out if there is anything beyond our galaxy. But for Hale, high altitude is just the first step. To see deep into the cosmos with stunning clarity, he needs his new observatory to house the biggest telescope in the world. Telescopes are like light buckets. The larger the telescope, the more light it can gather, bringing the faintest stars into focus. But Hale faces a challenge. Most telescopes at the time use glass lenses to focus light. But when glass lenses get really big, they bend under their own weight, causing distortion. Glass lenses just can't get any bigger. What Hale needs is a radical new design. A giant telescope that can collect a lot of light, but which doesn't use lenses. So Hale turns to a telescope first created by Isaac Newton in 1668. The reflector. This kind of telescope uses a curved metal mirror instead of glass lenses. It focuses light by reflecting it to a point. Now, Hale is planning to build one on a scale that has never been seen before. Only revolutionary engineering can support the gigantic instrument he plans, and the project will take 11 years to complete. The curved mirror spans 100 inches in diameter and weighs 9,000 pounds. It sits at the bottom of a 40-foot cast iron tube, housed in a 100-foot diameter dome. Finally, in 1917, the biggest telescope the world has ever seen sparks wonder amongst the public.
The scientific eye of America. To this mecca of stargazers flock astronomers from all nations.
In the pantheon of telescopes in astronomy, Mount Wilson, it is no exaggeration to say, is probably the most important telescope in the history of cosmology.
Discoveries that were made here really put it onto the map.
This great telescope is soon directed towards one of astronomy's most enduring mysteries. Strange, fuzzy clouds of light hanging amongst the stars have puzzled astronomers for years. They are the nebulae. Some are egg-shaped swirls, others are delicate spirals of stars. Others have branching tentacles. Thousands of them are visible through telescopes, but nobody knows what they are or how far away they are. Some astronomers believe that certain types of nebulae could lie outside the edges of our Milky Way galaxy. They wonder if they could be island universes, galaxies like our own. If so, this would shatter the limits of the universe and our understanding of it. But they have never had the technology to solve the mystery, until now. Hale invites the world's best astronomers to help crack the mystery once and for all. Among them is a young man called Edwin Hubble.
Edwin Hubble was one of the greatest observational astronomers ever to have lived. He made a tremendous number of important discoveries.
Night after night, Hubble examines the nebulae with the 100-inch telescope. He examines one in particular, the Andromeda Nebula, which Hubble can now see in unprecedented detail.
It would be this 100-inch telescope that would finally be powerful enough to bring the nebulae within reach and would start a series of discoveries that just completely changed our understanding of the universe.
Hubble can see stars within the Andromeda Nebula, But to find out if it really is an island universe outside the Milky Way, he has to find out how far away it is. But that is not an easy task. Establishing distances in the vastness of space is one of astronomers' biggest challenges. Stars, like car headlights, appear brighter the closer they are. If you know their true brightness, you can work out their distance. It's like knowing the wattage of a light bulb. If you don't know this, you have a problem. As NASA astrophysicist Kim Weaver explains.
At that distance, the headlight on that car appears to be the same brightness as the headlamp on this bicycle.
But as the headlights get nearer, it becomes obvious that their true brightness is in fact greater than that of the bicycle lamp. It's the same with stars.
If we know how bright a star is intrinsically, we can work out how far away it is from us. And that's what we call a standard candle.
Luckily for Hubble, astronomers had recently discovered a special type of star with a true brightness they can calculate. It is called a Cepheid variable. And it's recognizable because it pulsates over a period of days. All Hubble has to do now is find one of these stars in a nebula like Andromeda. At night, he scans the heavens with the 100-inch mirror. By day, he analyzes the photographs he has taken, hunting for any stars that have changed brightness. Then, on October 6, 1923, after months of work, Hubble strikes gold. A Cepheid variable on the edge of Andromeda.
I'm looking at the original discovery plate of Edwin Hubble's, where he first found a Cepheid in the Andromeda galaxy. And he actually marks on this plate between two black lines where the position of the Cepheid is, and he writes VAR exclamation mark when he realizes it's a Cepheid. So he's compared two different plates, and he's discovered that this thing is actually changing in its brightness.
Hubble can now make a measurement that will change history. The distance to one of the nebulae. He works out that Andromeda is about 800,000 light-years away. That's more than 8 times the distance to the furthest known stars in the Milky Way. This means Andromeda has to be outside the Milky Way, a whole new galaxy beyond our own.
This is irrefutable evidence. He's very excited. He writes it with an exclamation mark because he realizes the significance of the discovery.
Hubble's discovery explodes the frontiers of our universe. Our Milky Way galaxy is no longer all there is in the cosmos. Hubble goes on to discover that Andromeda is not alone. He reveals that dozens of nebulae are actually other galaxies.
Edwin Hubble's research with telescopes profoundly changed our view of the universe.
The most powerful telescopes of today are still exploring the wider cosmos that Hubble first discovered. Looking across billions of light years, they have uncovered 100 billion new galaxies beyond our own, each made up of 100 billion stars. Multiply those together, and you have more stars than all the grains of sand on all the beaches and all the deserts on Earth.
Just like that, the universe became 100 billion times larger.
Hubble's discovery that there were other galaxies outside our own blows the universe wide open. But what he discovers next will be even more extraordinary. Several years earlier, other astronomers had discovered that many of the nebulae, now identified by Hubble as galaxies, were moving away from us. Now, Hubble wants to work out why, and he will do it by analyzing light itself. He uses a method first discovered in the 1800s.
This is a spectroscope made in about 1880. One of the first generation of instruments used for analyzing the light from the sun. It's an instrument like this that transformed astronomy, because you can decode the light in a way that you'd never imagine.
The spectroscope splits white light into its rainbow spectrum of colors, and hidden in this spectrum are clues to the behavior of the stars. Light is made up of waves, and each color has its own wavelength. Blue light has a short wavelength. Red light has a longer wavelength. But when a galaxy is racing through the cosmos, the wavelengths of the light appear to change from our perspective on Earth. If the galaxy is moving towards us, the wavelengths get squashed and appear more blue. If the galaxy is moving away from us, the wavelengths get stretched out and appear to become more red. We call the effect redshift. It's like a cosmic speedometer. The faster a galaxy is moving away from us, the more its light waves are stretched towards the red. Sound works in much the same way, because it too is made up of waves. As astronomer Alex Filipenko explains.
Oh, this is going to be great. I'm going to blare on the horn now. Here we go. The pitch of the sound is constant, even though the car is speeding down the road.
In the driver's seat, Filipenko hears the horn at a constant pitch. It doesn't change. But now he wants to hear what the horn will sound like if he stands on the roadside, and the car drives past him.
When the car was coming toward me, the waves from the horn were being squished together, so the pitch sounded higher. And as the car passed me and moved away, the waves were stretched apart, so the pitch sounded lower. So it sort of went like that. If that blue car had been going fast enough, the high-frequency blue light would have been stretched apart. Then the blue color would have shifted all the way to red. The car would have looked red to me. That's known as a redshift.
Back in 1928, Hubble is looking at the redshift of his new galaxies to find out how fast they are moving. He sets out to chart the speeds of galaxies both near and far. He wants to see if he can find any correlation between how fast they're moving and how far away they are. Night after night is spent painstakingly analyzing the light from galaxies. The final results are staggering. Hubble discovers that the farther away a galaxy is, the greater its redshift, so the faster it is moving away.
By 1929, he had established a very interesting relationship between them. The nebulae that are farther away are moving faster away.
Hubble comes to an astounding conclusion. The universe is expanding. The galaxies may look like they are traveling away from us, but in fact, it is space itself that is stretching apart.
Here's a good analogy of how the expanding universe works. Now this is a hypothetical one-dimensional universe where the ping pong balls are the galaxies and the hose is the space between them. As the space expands, all of the ping pong balls recede away from one another. And every bit of space expands. The more space there is, the faster the distant one looks like it's expanding away from us.
Hubble's discovery is one of the greatest breakthroughs in the history of astronomy. The universe is not static. It is growing bigger and bigger.
These galaxies are moving apart from one another because space itself is expanding between the galaxies. That was a marvelous discovery.
Hubble could never have made his discoveries without the 100-inch telescope on Mount Wilson. High above the plains of New Mexico, one of the most advanced telescopes of today is taking Hubble's groundbreaking work even further. The Sloan Digital Sky Survey is analyzing starlight from hundreds of thousands of distant galaxies. Each aluminum disk is a galaxy map for a small part of the night sky.
So we've got 640 holes on an aluminum plate. Each hole corresponds to a galaxy, many millions of light years away.
Optic fibers link each hole to a high-tech version of the spectroscope used by Edwin Hubble. It will measure the redshift of the galaxies. Then technicians insert the map into the base of the telescope and match it up to the right section of the night sky.
So you can get 640 spectra at once, which is a great way to get a survey done, much better than once at a time.
This survey has now calculated the speeds of over 930,000 galaxies, giving us a far more precise image of the universe we live in and how fast it is racing apart. But back in 1929, Hubble's discovery begs a new question. If the universe is expanding, what is it expanding from?
Hubble saw and realized that things were moving away from each other, and the natural leap from that is, well, if things are now moving away, weren't they all at one time in a central location?
Astronomers put forward a revolutionary theory, the Big Bang, a single moment in time when the universe was born. The idea is so revolutionary, scientists struggle to make sense of it.
We had no way to observe this phenomenon. It made no sense to people at the time. Even Einstein didn't believe in this idea. We didn't have the belief that it might happen, and we also didn't have the telescopes to observe the effects of the Big Bang.
To find the proof, astronomers will need a completely different type of telescope, one that can see what our eyes cannot. Beyond the colors of visible light are the rays of the electromagnetic spectrum that our eyes cannot detect. Gamma rays, X-rays, radio waves and microwaves may be invisible, but they are crucial for astronomers. They hold the keys to some of the most violent events in the universe.
The human eye is only sensitive to a very small part of the electromagnetic spectrum. These are all the waves that behave like light. But we have been able to see in parts of the spectrum which are not visible to the human eye.
(1964). Astronomers Arno Penzias and Robert Wilson are working with a new radio telescope. Its giant antenna enables them to measure microwaves and radio waves in space in the form of heat. They expect the stars of our Milky Way to emit a faint glow, But when they point their antenna to empty space, where there should be nothing at all, they discover something very unusual.
We expected to find the sky away from the Milky Way to be quite cold, to be very close to absolute zero. And instead we found, to our very great surprise, that it was about 3 degrees hotter than that.
The mysterious signal seems to come from every direction.
We had a noise, a signal, if you want to call it that. Could be radio noise sources or it was something else, but I had no idea what it was.
Penzias and Wilson suspect that there is a defect with the equipment which is causing interference. They try everything, even sweeping the pigeon droppings from inside the antenna.
It didn't go away from winter or summer, day to night, seasons. We looked at every possible direction. There was a high-altitude nuclear explosion 2 summers ago, so maybe there was something in the atmosphere, charged particles. I didn't know.
Penzias and Wilson are at a loss until they hear about the work being carried out by a team of scientists just down the road at Princeton University. Robert Dickey and his colleagues have worked out that the afterglow from the Big Bang should still be felt today. They have even calculated the temperature, 3 degrees above absolute zero.
So I called up and I dialed Bob Dickey's office. And I happened to get him. And what I learned afterwards was that he put down the phone and he turned to his colleagues and he said, "Boys, we've been scooped."
Penzias and Wilson have unwittingly found the first physical evidence of the Big Bang. Their radio telescope has picked up the afterglow of the beginning of the universe. It remains one of the most important discoveries of all time.
I had no idea that we were listening to the echo of creation.
In 1978, Penzias and Wilson received the Nobel Prize.
To be on a list with Albert Einstein, to be on that same row, was almost too much. It was too much to bear. I just couldn't think of comparing myself against the people who have won Nobel Prizes.
In 1964, when the background radiation from the Big Bang was discovered, it was for the first time direct evidence that there was a hot Big Bang, an origin to our universe.
Penzias and Wilson have found direct proof for the Big Bang. But it will take another 37 years and far more sophisticated microwave technology before we discover how the Big Bang formed the universe we see today. Heading to an orbit 1 million miles from Earth is the Wilkinson Microwave Anisotropy Probe, or WMAP. A super advanced version of Penzias and Wilson's giant antenna, armed with 2 reflecting telescopes. WMAP's mission is to examine the afterglow of the Big Bang in extreme detail and to try and find out why galaxies formed.
With WMAP, we were trying to look way back to the very, very earliest times in the universe.
After a year of recording, the first results are mapped.
The WMAP observations were incredible. Instead of a smooth background radiation, you could measure to 1,000th of 1% changes in the temperature across the sky.
WMAP shows that actually there are tiny fluctuations in temperature.
The dramatic looking temperature changes here are actually tiny, going from a redder, hot spot here to a bluer cold spot is only a change of a couple hundred millionths of a degree. So it's really tiny temperature changes, but a very dramatic pattern over the sky, which has revealed tremendous information to us.
The tiny red spots are where matter is beginning to come together, and where clusters of galaxies will eventually form. This is vital evidence, clues to how stars and galaxies first came into being. The WMAP data helps astronomers work out what happened at the very beginning of the universe, right after the Big Bang.
We can actually deduce from that things that happened in the first trillionth of a second of the universe. And I think that's just extraordinary to be able to probe that early in the history of the universe.
And WMAP's accuracy allows astronomers to solve another great cosmic mystery: the exact age of the universe. For the first time, astronomers have an accurate figure.
We now know that the universe is about 13.7 billion years old. That's very old, but it's not infinite. It could have been infinite, but it's not. One of the great discoveries of 20th century science.
WMAP has taken us further from the Earth and closer to the very birth of the cosmos than any other telescope in history. It is revealing the edges of the universe in unprecedented detail. But the microwave data it records is invisible to the human eye. Would it ever be possible to see the very first galaxies in the universe in ordinary, visible light? Only if optical telescopes also take a giant leap in technology and head for the skies.
Liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
NASA launches the most famous telescope ever built.
If you ask any person on the street to name a telescope, they will say the Hubble Space Telescope.
Roger, roll, Discovery.
The Hubble Space Telescope is probably the most productive telescope in history. It has been compared to the time when Galileo lifted his telescope to the sky for the very first time.
The 12-ton Hubble Space Telescope is a fitting tribute to the man who first took us beyond the edges of our galaxy.
Mission Control Houston, standing by for SRB
It bursts
separation.
through Earth's atmosphere and is released into orbit 370 miles above us. Ever since Hale built his observatory on a mountaintop, astronomers have dreamt of having a telescope in space. Here, far above the interference of the Earth's atmosphere, there's no haze, smog, or cloud to obscure the light streaming in from the universe.
Putting a telescope in space gives us an incredibly clear view of the universe. We have seen further and deeper with the Hubble than any other telescope in history.
And Hubble is looking at light that is visible.
What we are able to do with the Hubble is essentially capture the images as though you had 2-meter eyes and you were in a vacuum and you could hold them open for a week. This is what you would see. They're not computer creations, they're actually digital pictures that you can actually see.
The crystal clear images taken by Hubble are some of the most extraordinary visions of space ever seen. The remains of exploding stars streaming through space. Vast clouds of gas and dust where new stars are being born. Distant galaxies spiraling in giant disks and colliding to create supergalaxies.
My favorite image, I think, must be the Butterfly Nebulae. It's a nebulae that has gas streaming out at 600,000 miles an hour. telescopes are time machines. We're seeing photons that actually started their journey 13 billion years ago and have taken that long to traverse interstellar space to us. And so you're not only looking out into space, you're looking back in time.
In 1995, Hubble's ability to look back in time is put to the test. Astronomers decide to turn its gaze onto one dark point in the universe, just to find out what they can see.
We picked one tiny point in the sky in which there was essentially nothing there or nothing special there.
We stared for 10 days at a single dark spot on the sky.
It is as if Hubble is peering through a tiny keyhole of our Milky Way galaxy to the universe beyond.
The size of the spot that we looked through was no more than a drinking straw.
What Hubble sees is extraordinary.
And what we saw were 10,000 galaxies in that single spot.
Every point of light that you see in the image represents a galaxy with 100 billion stars like the sun.
The image is called the Hubble Deep Field. It shows light from galaxies 4 billion times fainter than anything we can see with the human eye. Light that set out on its journey billions of years ago.
If there is something that gives you a sense of the size of the universe and its depth, it's this kind of image.
Every time the Hubble Space Telescope has been serviced by astronauts, the camera has been upgraded. After NASA's final mission in 2009, a new deep field image reveals the furthest galaxies ever seen, only 600 million years after the Big Bang.
We're seeing back as far as we can see, because we're seeing back to the time of the births of galaxies.
The Hubble Space Telescope is taking images that continue to amaze us.
I believe that the Hubble Space Telescope, in some sense, has been really unique in the history of science. It has taken really the excitement of discovery and has made it, to belong to every home, to humans all across the globe.
Hubble has revealed the mysteries of our cosmos in stunning glory. Now, it is working within a vast network of modern super telescopes to investigate a discovery that has rocked the world of astronomy. A discovery that threatens to turn everything we thought we knew about the universe on its head. An enigmatic force called dark energy.
Dark energy is the most mysterious thing we've ever discovered.
It's an energy that seems to be created out of nothing, out of the vacuum, but we have no idea what it is.
Dark energy's discovery comes as a complete surprise. In the mid-1990s, on Mauna Kea, Hawaii at the Keck Observatory, a team of astronomers, including Alex Filipenko, is scouring the distant cosmos. They know the universe has been expanding, but will it really expand forever? They have a theory. The universe might actually stop expanding and start slowing down.
Just like when I throw this apple in the air, the gravitational attraction of the Earth on the apple slows it down and eventually stops it and reverses its motion, so too all the galaxies pulling on each other could slow down and ultimately stop the expansion of the universe, to be followed then by the collapse of the universe into a big crunch.
So is the universe really beginning to fall back in on itself? To measure the speed of the very edges of space, astronomers need the most powerful telescopes on Earth. The giant mirrors of the Keck telescopes are 33 feet in diameter. Made not from one single disc of glass, but 36 hexagonal mirrors working together. They give a single image of exceptional clarity.
The Keck telescopes are really fantastic devices. They can allow us to see galaxies that are literally at the visible edge of the universe, 10, 11, 12 billion light years away.
But to find out how far away these distant galaxies actually are, astronomers need a standard candle, a star that will act as a cosmic yardstick. But the Cepheid variable stars that Edwin Hubble used are too faint at the extremities of the cosmos. The astronomers need to hunt for an especially bright kind of star inside the furthest galaxies.
There, if you squint, you can kind
The
of...
deaths of these stars cause some of the most devastating explosions known to humankind. They are called supernovae.
A supernova is quite literally an exploding star. Now, most stars don't explode at the end of their lives, but a few completely disrupt themselves in a colossal, titanic explosion.
And not just any type of exploding star will do. They're looking for a type of supernova that explodes with a very intense and consistent brightness. A type 1A.
They go off as a gigantic nuclear runaway. They're essentially a gigantic nuclear bomb.
In the most distant galaxies of the universe, they find what they are looking for. Type 1A supernovae.
That looks good. There it is, there it is. Yeah. Look at that.
Yeah.
It's a little bit fuzzy.
Now they measure the redshift to calculate how fast these distant galaxies are moving away. Finally, in 1998, after years of research, they come to a shocking conclusion. The expansion of the universe isn't slowing down at all. It's speeding up.
Much to our surprise, we found that the universe is expanding faster now than it used to be. So instead of slowing down, it's been speeding up. So it's like the apple goes zoom like that. A completely fantastic conclusion.
A mysterious force that no one can see is defying gravity, pushing the universe apart faster than ever. It is the force astronomers now call dark energy.
There's the possibility that Einstein's gravity is incomplete, that we don't understand gravity. There's a possibility that it could change some of the fundamental laws of physics.
But what dark energy actually is, and what it will do to our universe, remains a mystery to this day.
Dark energy is one of the keys to understanding the fate, the ultimate fate of the universe. Is it going to expand forever?
Will it continue to speed up? Will the speed up, in which case the whole universe gets ripped apart?
The one thing astronomers do know is that dark energy makes up most of the universe.
We discovered since that this dark energy is some 72% of the energy density of our universe, and yet we don't know what it is. I mean, just so that you understand the level of the puzzle, I mean, you know, about 70% of the surface of the Earth is covered with water, right? Imagine we didn't have a clue what water was. This is the situation we're in.
As if one invisible mystery isn't enough, scientists at NASA's Jet Propulsion Lab are investigating an equally mysterious invisible substance: dark matter.
Dark matter is basically invisible. We can only see it by looking at how it distorts things that are behind the dark matter.
Images taken by the Hubble Space Telescope are now helping to reveal where dark matter can be found in the universe. Hubble's images show that this invisible substance is bending light.
A good analogy is a pool of water. If you went out and you threw a penny into the bottom of the pool, you would look down at that penny, and you can see the penny very clearly because the light from the penny is coming through the water. The water is essentially invisible. But the shape of that penny is distorted because that light travels not a straight path, but a slightly curvy path through the water to come to our eye.
Dark matter has a similar effect. It exerts a powerful gravitational pull on light from distant galaxies.
So what we're looking at here is light from a distant galaxy coming to us through this dark matter distribution. And as the light goes through the dark matter distribution, the path of the light is bent.
Astronomers calculate that dark matter makes up 23% of the universe. Add that to dark energy, and that leaves just 5% of the entire universe that is not invisible. So after 400 years of searching the heavens with telescopes, we still have 95% of the universe to reveal. And a new quest is beginning. A new generation of telescopes, millions of miles in space, high on mountaintops, and deep below the Earth, is gearing up to change our understanding once again.
Telescopes are actually at the forefront of changing the way we think of the universe because it's the only way to see the universe.
So these big, giant new telescopes are trying to address some fundamental questions. What's the nature of the universe that we live in? What is the stuff that makes up the universe? Could there be life elsewhere in the universe?
The most sensitive scientific instruments today are not just looking at detectable light. They are searching for the invisible, and they will reveal mysteries of the cosmos beyond our wildest dreams.
There's a whole hidden universe out there, and that's what we're trying to discover.
Since the time when telescopes were first raised towards the heavens, we have been hunting the edges of the universe. Revolutions in technology and the race to build bigger, higher, and even in space have given us discoveries that have been revelatory, earth-shattering, and profound.
We now know how little we are compared to the extraordinary size of our universe.
We are even on the brink of discovering planets with the building blocks for life.
Are there Earth-like planets? Could there be life elsewhere in the universe? One of the exciting things about these big telescopes, they're very likely to give us the answers to these questions.
At each stage, we have pushed the boundaries of our universe further. Beyond our planets, beyond our galaxy, beyond the 100 billion other galaxies, and virtually back to the Big Bang and the beginning of time. Telescopes are changing everything we thought we knew about our tiny planet and its true place within the cosmos. Who knows what they will reveal in the future?
If we're going to look back in another 100 years, I think the whole world and our view of it will be transformed yet again.